Dispersive power of grating. This dispersive power of grating is equals to d theta by d lambda. And this d theta by d lambda is nothing but d theta is difference in diffraction angle between any two spectral lines. D theta is difference in diffraction angle between any two spectral lines divided by difference in wavelengths of these spectral lines. We have done the experiment spectrum where we studied the spectrum of white light in which you saw different color lines. That different color lines are called spectral lines. So this d theta is the difference in diffraction angle. For each color spectral line, the diffraction angle is different. For example, if you choose the green light and red light, they have certain diffraction angle. And the difference in the diffraction angle of this green and red color light divided by difference in wavelength of this red and green spectral lines. That gives us dispersive power. So this dispersive power can also be defined as definition of this d theta by d lambda. D theta by d lambda is nothing but rate of change of diffraction angle with respect to wavelength, called the dispersive power of the grating. We know the equation for principal maxima in case of grating. So the equation for maxima, equation for principal maxima of grating is a plus b sine theta is equals to n lambda. Let us differentiate this equation on both sides. Differentiate this equation on both sides. So the differentiation is a plus b cos theta d theta is equals to n d lambda. And you know the dispersive power is d theta by d lambda. Therefore, d theta by d lambda is equals to n upon a plus b cos theta. A plus b is d, and 1 upon a plus 1 upon d is equals to number of lines per unit. So this equation you can write as n into n prime upon cos theta, where n prime is equals to 1 upon a plus p, which is nothing but number of lines per unit, can be centimeter, millimeter, whatever. So this is the dispersive power of grating. And from this equation, we can conclude that conclusion. The conclusion is, the first conclusion, dispersive power, which is d theta by d lambda, is directly proportional to n. N is order. This means angular separation doubles for second order, and so on. Angular separation between the spectral lines doubles for the second order. That is, dispersive power is directly proportional to the order. The second conclusion is dispersive power d theta by d lambda is directly proportional to n prime. N prime is number of lines per unit. As this number of lines per unit increases, dispersive power increases. And the third conclusion is, for smaller theta, this cos theta would be approximately equals to 1. Then we can write that this d theta is directly proportional to d lambda. That is, d theta is angular separation. Angular separation is directly proportional to d lambda is difference in wavelength. So angular separation is directly proportional to difference in wavelength. Then such spectrum is called normal spectrum. When d theta is directly proportional to d lambda, that spectrum is called normal spectrum.